Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
Well, let's get into it. Now, the reason why I've given you these exercises to do was to see how well you know your set notations, right? And the basics can come back to haunt you if you're not paying attention, right? So the first question, I'm going to go through it. Keep your hands up, those who completed it. Yeah. So the first question, A complement union B complement is equal to, and you want to know the elements of that set, right? And here is our Venn diagram. Now, I told you guys the easiest way to do these set notations, once you understand the notation, it's easy, right? So A complement just means everything that's not in A. So let's list that first. Let's go and list. I know this is long, the long way of doing it, but you can't go wrong like this, trust me. So A complement means everything that's not in this circle, A. So that is the 7, 5, 6, 8, and 9. So we're looking at 5, 6, 7, 8, 9, right? Those are the elements that are in A complement. And B complement, right? Union B complement. So we're looking at B complement as well. And B complement, similar to A complement, is just what's not in B, right? So looking at the circle B, 4, 5, and 6, those are the elements of B. B complement would be our 2, 3, 7, 9, and 8, right?
Sorry about that. I get both.
Yeah. Right. 2, 3, 7, 8, and 9. So we have A complement and B complement. Now we want A complement union B complement, which means that you're uniting the two sets. We're uniting A complement and B complement. So let's put the unite, it united. And let's, for the sake of convention, let's do this in ascending order, right? The numbers in ascending order. So we have 2, 3, 5, 6, 7, 8, 9, right? 2, 3, 5, 6, 7, 8, and 9, right? And that is, and those are the elements of A. Oh shoot, I can't erase that. So I will just have to I just have to leave it like that. But yeah, those are the elements of this set notation. A prime, A complement, sorry, a different subject I'm thinking of. A complement union B complement. These are the elements, right? I remember we don't write the same element twice, right? So the 7, 8, 9 there, that's repeating twice. So right away, if we were to do the intersect, meaning what's in both sets, if we were to do A, well, it's right here. It's already there, right? So we can jump straight ahead and do number 4, looking at these, right? You could do, yeah, just number 4 you could do. You're looking at these sets, right? So number 4, jumping straight ahead, A complement, intersect, B complement. It's an intersect, so we're looking at the elements that are in both sets, and it's best to circle these like this so that you can see it clearly. The elements that are in both sets, right? Baby stuff, but yet it works, right? So looking at 7, 8, and 9. So number 4 would be 7, 8, and 9. Again, I can't. But right, so we got now 1 and 4. Next is number 2. We're looking at A intersect B complement. Again, we have B complement already, so we don't necessarily need to go ahead and write down B complement, but we can write down A. We can write down A and B. We don't need B, but for the sake of right? We know A is 2, 3, and 4 based on what's in the circle, and B is 4, 5, and 6. Right? And we're looking at A intersect B complement, meaning that we're looking for what's in A and B complement, right? The intersect. Right? So what's in A is 2, 3, and 4. In B complement, 2, 3, 7, 8, and 9. Again, you can't go wrong if you circle them like this. And that's about it, right? In A intersect B complement. So it's just 2 and 3. Right? Now, number 3, last question. Well, last question we're working because we skipped to number 4 already. We have A union B complement in brackets complement, right? To do this is a simple, work the bracket, get the elements of the bracket, and then what's not in that, right? The elements are not part of that set, right? So find the elements of the set A union B complement, and then the elements that are not in that set. That's the answer, right? That is the element of the complement of that notation. So let's first look at A union B complement, right? And we have A is 2, 3, 4. And then B complement would be, again, we don't write the same thing twice. So B complement would be 7, 8, and 9, right? 2, 3, 7, 8, 9. Simple as this. And now these are the elements of A union B complement, but we don't want this. We want what's not in here, right? We want not in here. So what would be not in here would be everything that's in the universal set, but not in this set. That's what the complement sign means, right? Fundamentally, that's what it means. So if we want to know what's not in here, let's write down the universal set, which just starts from 2 and goes all the way up to 9. Or you could just look at the Venn diagram if you want, right? But I'm writing it down so I can do this like this. I'm just going to put a star at what's in our set A union B complement, right? 2, 3, 4, 7, 8, and 9. The only 2 elements that are not in that set, but still within our rectangle or universal set is 5 and 6, right? So this is 5 and 6. It's as simple as that. Once you know your set notations, just ignore the fact that this is here. So once you know that you know your set notations, it's as simple as just you can write down the sets in a corner. Sometimes you can see, like for instance, I can see A intersect B is 4 right away. You don't need to go ahead and do this. But this, you can't go wrong if you take your time and do it like this, right? You can't go wrong, at least you shouldn't. We're looking at number of elements in a set. There's a few things that you need to note. Right. So the set notation here is N, open bracket, the name of the set, close bracket, right? So I mean, instead of writing name of set, and this means number of elements in. So I don't write it like that. Right, this is what we refer to as number of elements in the set. Right. But so N open bracket, the set notation, not necessarily set notation, the variable assigned to that set, right? The variable name of the set, whichever one you want to call it. It's the once that is in bracket where the N open bracket, the variable name of that set, that's the number of, you're referring to the number of elements in that set, right? This is the notation for that, right? So an example would be, let's look at a set. Let's look at a set A and use the normal 1, 2, 3, 4, 5. Right, these are the elements of set A. And if I want the number, refer to the number of elements in set A and open bracket. A, this means again number of elements in the set A, right? In set A. And so n open bracket A would be equal to 5, right? It's easy to count when you write the numbers like that. And this would be equal to 5. So when we're looking at, so this is the key step. This is the notation that you need to know before we get into anything, right? N open bracket, the set, it could be the variable name for the set, or it could even be a set notation itself. But you need to know this notation means number of elements in whatever set you're referring to. If it's a complement A union B complement, whatever set you're referring to, N open bracket, that set is the number of elements. So you have to go ahead and count the elements in that set. Now, using that with what we learned before, looking at Venn diagrams and also the set notations, we're gonna get into some problems. You're gonna use those to solve problems. And that's where number of elements in a set comes in. And this is where it becomes tricky. So you're using what you learned from Venn diagrams, also from set notations, and added to the fact that this new notation here, more or less, I expect most of you to already be familiar with this. It means number of elements in a set. You're using those concepts that you would have learned now to solve problems, right? And generally, this is how these, I believe, yeah, good. So we're gonna go through some questions, and you're gonna see how these questions are gonna come. Now, the first one, if A and B are sets, N open bracket A, and this is what I was showing you guys just now. N open bracket A is the number of elements in set A, right? And N open bracket B closed is the number of elements in set B. Simple as that. I just need to count. Now, example, if a class of students, yeah, if a class of 30 students, 20 played cricket, 17 played football, and 7 played both cricket and football, each student played either cricket or football, very important statement. Find the number of elements who played, the number of students, right? I already call them elements, but the number of students who played cricket only and football only. Now, one thing you're going to do as soon as you see questions like this, as in you're looking at a universal set, and the universal set now is the class. Right now, you have to start mapping the question onto sets. Right. These questions, as soon as you see this structure, the question structured in this way, you're referring to sets. Right? It's not blatant. You don't have a set. It's a set A and set B, and no, the questions are structured differently now, right? But you need to identify the sets and the number of elements in those sets. So if I were to refer to the class as a universal set, right? Usually when with the structure of these questions, usually the first bit of information is the universal set. How many elements are in the universal set? Usually, right? So in a class of 20 students means we're referring to a class of 30 students. I said 20. In a class of 30 students means we're referring to a class of 30. Now, using that as a universal set, U, right? N open bracket U is a universal set, or in other words, the class, right? You could use C if you want to represent class. I'm just using U. You could notate, you could use any notation you want. So number of students in the class would be 30, right? So that's the first bit of information we know is the number of elements in the universal set, right? Now, number of 20 played cricket, right? So 20 students that are in the universal set played cricket, right? We don't know their names. We don't know the elements in the set. All we know are the numbers, right? So 20 played cricket, that meaning let's use C for cricket. Could have been a controversy there if I had use C, right? So let's use C for who played cricket. So the number of students, or the number of elements in the set cricket would be 20, right? Simple as that. Now, 7 played football, right? 7 played football, hence 17, sorry. 17 played football. Let's use F for football. So the number of elements within the set football, meaning with F being played football, who played football, it's equal to 17, right? These are the things you need to start jotting down as soon as you see this structure, right? Now, 7 played both cricket and football, meaning that they're playing both cricket and football. Now, the key word there is both, right? The key word there is both. Now, we know when we refer to an element that is in both sets, we're looking at a intersect, right? And looking symbol, right? So if we're playing both cricket and football, we're referring to the intersect, and hence the number of elements in the intersect of cricket and football. Again, we're using our N and F, C and F is 7. Everybody following so far?
Yes, sir.
Yes. I'm waiting to hear a no. Say no if you want me to go back.
Yes, sir.
Yes, you want me to go back, or yes, you're following?
Yes, I'm following.
All right. Okay, good. So we identified all the this is your toolkit here, right? This is your toolkit here. Now, each student played either cricket or football. Anybody want to figure out what that tells us? Each student played either cricket or football. Anybody want to take a shot at what that tells us? It's not a number, but yeah, Denisha.
Intersection.
Intersection. Well, no. Or means union. Now, or is union, right? Or is union. The keyword for union in these number of elements in a set, you will see these keywords will pop up all the time. So you see both, you're talking about intersect. So you see or, either or, and so on. You're talking about a union, right? However, I still want, but I didn't give us any number, but let me see if anybody's, if y'all had on here. Each student played either cricket or football.
It's saying that there is no number, nothing outside of the two sets.
Correct.
So, yeah.
That's one of the most important things. It means they're saying that there's nobody in this this class that's not playing cricket or football. Very athletic class. Everybody's playing a sport, right? So that means 2 things. It means that if we were to think of it as a Venn diagram, right? You can see the Venn diagram just now. But if you think of it as a Venn diagram of cricket and football, there would be no one outside here, right? Because they're either playing cricket or football. It also means that the number of elements in, yikes, I'm writing all over the place now. Let me just say that I'm talking about this. Yeah. So the number of elements in cricket union football, the number of elements in cricket and football, the sum of the persons playing cricket and football would be equal to, somebody complete my sentence, would be equal to 30. Right, would be equal to 30 because everybody playing some sport. So the number of elements in C union F is 30, and that's what we got from this statement. So what you notice, what we did is each statement we picked out a notation, right? We picked out a notation for a set, and then we also figured out the number of elements in that set, right? And that's what you're going to do when you see questions like these, right? That's what you're going to have to do. Now, that unfortunately is not what they're asking us to do. They're asking us for what, who played cricket only. Once you can figure this out, I can give you a simple formula that works all the time. Once you could figure this out, you're set. Once you follow the formula that I'm about to show you, you could just reason it out. You could use your reasoning to figure it out, or you can follow a simple formula. You could remember a formula, right? And that's this gibberish that I have on this slide. The formula is here. One of the formulas there, at least. Good. Now everything's on the side already. So everything I would have explained most of this already, right? So let's see equal the number of students. The students who played cricket, F, the students who played football, then N, the number of elements in C, that's the number of students who played cricket, is 20. We know that, right? We plug that out from here. I did this so you guys can see where everything came from, right? We know that. So next, the number of students who played football, or number of elements in the set F, is 17. The number of elements in C intersect F, that's playing both cricket and football, is 7. And last but not least, the number of elements in C union F is 30, because everyone's playing cricket or football. And as I said before, don't forget these keywords. Or means union, both means intersect, right? You'll see that again pop up later. So if we want the number of elements who played cricket only, we can do, this is a set notation. You remember the set notation for cricket only would be C intersect F complement, right? We put the complement sign, we put the intersect and the complement sign on the football, which is the one we don't want. We want C only, right? Remember those set notations, right? Good. So C intersect F complement, this means cricket only, would be equal to a number of elements that play cricket minus the number of elements in C intersect F, right? And that's usually the formula to find any set only, the only of any set. You would just subtract the number of elements in that set subtracted by the intersect. And think about it logically. When we look at the Venn diagram, you see why that makes sense, right? So the number of elements of cricket, right, or number of elements in set C minus the number of elements in C intersect F, that's 20 minus 17 gives us 13. And this is how many students that are playing only cricket, right? Next is football only. Part B is football only. And same thing, but this time you're looking at football only, right? And remember the set notation would be F intersect C complement. Again, the complement sign swaps. Just swap the complement sign on the two. Yeah, just swap the complement sign. And now we have F intersect C complement, which is football only, is equal to the number of elements in football, right? Number of elements in the set F minus C intersect F, right? The intersect, which is the same as 7. So we have 17 minus 7, and that's equal to, yeah, and that's equal to 10, right? So 10 students are playing football only. So putting this on the Venn diagram, the universal set would be equal to 30. And only here would be equal to 13. In the middle here would be 7. This is in both sets. The intersect is 7. So 7, 10, the only, right? This guy is 10 only. And here would be 13 only. Now, the reason why I said this formula, if you remember the formula, but the reason why I said logically makes sense is if I told you, if I told you 7, there is 13 people, let's use the numbers we have there and don't let me count the numbers. If I told you there are 20 students playing cricket, right? And out of those 20 students, 7 are playing both cricket and football. How much are playing only cricket? you would just subtract the 2, right? Logically, that makes sense. So that's where the formula came from, right? Just simple deductive reasoning. And also, if we were to look at the Venn diagram, right? This circle, this part of the circle is the intersect. This is the 7. And if we want, if the entire circle, which is the entire set, is equal to 30, 20, not 30, I'm using 20. Yeah, saying 20 all the time. Yeah, so if the entire set is 20 and part of part of that set is 7, and you want to know what the rest of the set is, which is the only, you just subtract 20 by 7. Right? So again, if I asked you, if I told you there's 20 persons playing cricket, and out of those 20 students, 7 are playing both cricket and football, and I want to know how much are only playing cricket, you would just subtract the 2. Especially if I told you this, each student played either cricket or football. Let's take our time. The answers, never mind that the answers are already showing at the bottom here. Yeah, so of 100 athletes, and as I said, this is the first thing that should come. Of 100 athletes, we're looking at sets. The number of elements in the universal set is 100, and that's what's here, right? So the number of elements in the universal set is 100, right? Right away, write that down as soon as you see of 100. The first line, as I said before, and you're going to keep seeing that, is usually the number of elements in the universal set, right? So of 100 athletes, 31 like to walk, right? So 31 of them like to walk. So run, I'm saying walk already. Yeah, 31 is like I can't read. It's almost like I can't read. So yeah, 31 of them like to walk, right? So 31 like to walk, and therefore I'm saying walk still, I noticed, and therefore number of elements in R would be 31, right? 31 like 31 like to run. Now 65 like to walk. I like walking for some reason. So the number of elements in W, we can use W for walk. Just use the first letter for each, and you should be fine. Number of elements in W would be 65, right? Now we're moving on to this last piece of information here. 22 neither like to walk nor run, right? 22 neither like to walk nor run. Now I know it's already there, but 22 neither like to walk nor run. So you learn another keywords to look for. We didn't see both, which tells us that it's an intersect. We didn't see either or, which tells us that it's a union. We see neither nor, which could only mean that it's the complement of the union, right? Neither nor, either or. If either or is the union, neither nor is the complement of the union, right? Makes sense. Yeah, makes sense, right? Because you're talking about not neither. Neither nor is basically not either or. Simple as that. It's not either or, so it's neither nor, which is the complement of the union, right? So right away, neither 22 neither like to walk nor run. So now we do have elements outside those two circles, and that's 22, right? So the number of elements in, wait, there's two ways we can write this, right? Let's do the first way, which is W intersect R, with complement sign on both, of course, is equal to 22. Or we could write it the other way we know, which is number of elements, open bracket, W union R, close bracket, complement sign. Right, the other way to do it. Either way, the complement of the union is 22. Right, and I think that's it for keywords. Yeah, that's it for keywords. So now you're fully equipped to extract all the set notations from these statements, right? We will see how this could step up a level further when we look at the other example. So we have everything now. So determine the number of athletes who like to both run and walk. both keyword, they're talking about the intersect. So they want to know what's the number of elements in the intersect of run and walk. Right, so we got to figure out the intersect. And B, to run only again, and to walk only. And we know how to figure out, we know how to do the run only and walk only, right? You just use the number of elements in R, subtract the intersect, right? That's how you get the onlys. You just subtract the number of elements in the set, the total number of elements in the set, subtract by the intersect, and that gives you R, right? And do the opposite for W, do the same thing for W, and you'll be fine. However, this is a tricky guy, number of elements in R intersect W, right? So what's important to know is that the number of elements in R and the number of elements in W will also include the number of elements in both sets and not what is only in R, what's in R only and W only. This is here because a lot of students confuse this. But when you talking about the number of elements in R and the number of elements in W, you have to realize that you're including the intersect, right? You're including the intersect. And we want to know what the intersect is. Intersect, you more or less need this. You need to know this, right? So the intersect between two sets, doesn't matter whether it's R or W. The number of elements in the intersect between two sets is usually equal to the sum, right? So let me put this in bracket, in red brackets. Is usually equal to the sum of the two sets. Right, so N, so set R, number of elements in set R and number of elements in set W, subtracted by the union. And I wrote union and said intersect just now. If you ask me to do that and leave it, you know, correct me. Right. Yeah, so the intersect is usually equal to the sum of the two sets that are intersecting, subtracted by the union, right? Now, in this case, we don't have the union. However, we do have enough information to get us that, which is the complement of the union, right? So we know that the complement of the union is equal to 22. So it should be easy to get because what we know is the union will always be equal to, not the union, the universal set will always be equal to the union, would always be equal to the union subtracted by the union complement, the complement of the union, right? Makes sense. Everything in here would be everything in the circles plus everything outside the circles, equals the universal set, right? That's what I'm basically saying. So knowing that everything in the circle, I'm gonna have to shade everything in the circle here, right? This is what we want to find. We know the universal set, so we know this might get confusing a bit, right? So we know how much is everything here. That's 100, right? 100 is the entire rectangle, and we want to know what's this part of the rectangle, which is just the two circles. We want to know the union of the two circles. So we want to know the white, sorry, right? But we also know the outside of the circles, right? We know the outside of the circles, and that's the complement of the union, right? So if we know the entire sum and the part of the sum, you just need to subtract the two to get the difference, which would be our union. So what I'm saying is that the union will always be equal to, because in this case we don't have the union. Sometimes you may have it, sometimes you may not. And the union is always equal to the number of elements in the universal set subtracted by the complement of the union, right? The number of elements in the complement of the union. Right, good. And this will give us the universal set. This will give us the union, and then we use the union to get the intersect, and then we use the intersect to get the only, same like that, right? So let me go that over from the top. The intersect would be equal to the sum of the two sets, the entire set, right? Number of elements in R plus the number of elements in W, not the onlys, the entire set. So the sum of the two sets subtracted by the union is equal to the intersect, right? That's what we're going to give you, the intersect. And for the case where we want the union, we don't have the union, but you have the complement. The complement would be, the union, sorry, would be equal to the universal set or everything subtracted by the complement of the union, which makes sense because if we know the area of this entire rectangle and we have the spaces here, I want to know the difference. The remaining space will always be equal to the difference between the two, right? It's always the difference between the two. It's what's good, correct. So the first thing we need to know is we know that to get the intersect, we need to subtract the sum of the two sets by the universal set. We don't have the number of elements in the universal set. So that's the first thing we got to go and find, right? Number of elements in the universal set. And that is universal set, the union, sorry. And that is the universal set subtracted by the complement. Good. And as 100, we know the universal set is 100 and the complement is 22. Hence, the number of elements in the union is 78. Right? 78. Good. So we know the number of elements in the union. We can find the number of elements in the intersect by, again, it's the sum of the two sets subtracted by the union. Right? So the sum of the two sets. So let's go. Sum of the two sets. By the way, you can jump ahead in front of me if you haven't already. Subtracted by the union. And number of elements in R is 31 plus the number of elements in W, 65, minus our number of elements in the union, which we decided was 78. We get 18. Let me just write it back here. So now the elements in the intersect is 18. And now we want the number of elements in R only and number of elements in WONC only. And we know this, right? This is from the first example I showed you. If we want the number of elements in the onlys, right? So the notation for that would be this. We want the number of elements in the onlys, we need to do we need to subtract the number of elements in that set by the intersect. I need to do that for the WOC as well. Intersect or complement. In this case over here, no, that's 31 minus 18. Over here, 65 minus 18. Right, over here we end up with 13, and over here 47. I gotta so the number of elements in the yikes, right? So the number of elements in R only, which is again, don't forget the notations, would be 13, and the number of elements in, I'm just writing it back for the sake of the box. It's 47, right? And then walk only or W only is 47. Questions, queries? Example 3 is a CSEC question taken from January 2013. I said these earlier papers are usually difficult. And you see there, they put algebra in there, right? I know CSEC trying to confuse people. But remember the stuff that we already know. You just remember that, trust me, you'll be fine. So look at this. There are 50 students in a class. What I might do is walk through how to do the question, and I may not actually answer the question. Right? Find X is what I want. You just gotta find X. That's the only that's the only thing here. You have to find X. So this entire thing, we only need to find X and complete the Venn diagram. Now there are 30 students, there are 50 students in the class, sorry. Now that right there tells us the universal set. We could put it in here. Universal set is equal to 50 right away, right? The usual, the first statement. The students in the class are given awards for maths or science. So let's put maths or science. 36 students received awards in maths, in mathematics or science. Right away, somebody tell me the notation for this statement. Somebody quickly. We don't have a lot of time. We gotta write the notations for each one of these statements, so we know.
M union S equals 36. Well, N, the number of elements in M union S equals 36.
Correct. The keyword there being or. Right? Thank you. Now, 6 received awards in both mathematics and science. Somebody other than Kazako, give me the notations for this one. You can sit down here and watch one. I'll do till 6:30.
Sir, number of elements in M intersect S.
You know, pardon?
Sir, number of elements in M intersect S.
That's correct. Right. So M intersect S is 6. Right. And 2X students received awards for maths only. Somebody give me a notation for maths only.
M intersect S complement.
Yes, M intersect S complement. Once you're going for these onlys, it's always M, it's always the set intersect another set, the other set, complement sign on that other set. It's always that. That's how you do the onlys. Right, so N is N math only, the number of elements in math only is 2X, right? Not 2X, right? And X students receive award for science. So for science, we got, I should ask the notation. So what would be the notation here?
M complement intersect S.
Exactly. All right, so S, and let's put the S first. S intersect M complement, or you can put M complement intersect S, whichever one. Same thing, is equal to X. Simple as that. right? So what you want to know, let's complete the Venn diagram. So the intersect, M intersect S is 6, so the 6 goes in the intersect. You guys can fill this out. You guys don't need me to do this. What I want to get at is find X. Let's find, how do we find X? Right now I got it right. Yeah. So on the other screen. Nope. Let me find X right here. We're not gonna waste time writing everything out on the other screen. So good, let's find X. Now to find X, we know X is equal to science only. So at least we know that. Now, one of the equations we can use is what you need to notice is that the union, one thing you need to realize right away is that the union would be equal to, yikes, what's going on here? Come on, right, and go. Yeah, one thing you need to realize here is that the union would be equal to the intersect plus the math only plus the science only. Makes sense? I'll show you just now. I'll explain. Space. Try to write small, that's what happens. Yeah, so the union, I think it's about 6:30. Yeah, so the union would be equal to the intersect of the two sets plus the only height of the two sets, which makes sense. We squeeze it in. Yeah, all right. So this is the intersect, the only and the only. That's because if I want to know everything inside these two circles, what's inside these two circles together? The union would be to unite both circles. And if you notice the unity of the two circles includes the only, which is this portion, M only, which is here, plus the intersect plus the S only. So that's where this came from. So the union is equal to, so that's one thing you need to you would have recognized is that the math only plus the intersect plus the S only makes the union, right? Makes the union of the M and the S. Right? The union of M and S is equal to M only plus S only plus the intersect. Right, so with that, just plug numbers, plug the expressions for each variable. So number of the union is 36 and the intersect is 6 and the M only is 2x and the x only, the S only is x, right? And 2x plus x is 3x, right? So 36, 6 plus 3x. And then we have simple changes I've got the formula now to get our x, right? So let's transpose. Here is addition, transpose this over, this 6 is adding, transpose it, it becomes subtraction. So 6 minus, and the 3x is left over here. 6 minus 36, 30. I already write 10. Yeah, jumping way too far. So 3x, we left with 3x, and now divide both sides by 3 or carry the multiplying 3 over, same thing. And we end up with x is equal to 10. I have to speed that up a bit. X is equal to 10. We found x, and you more or less could label this diagram. I will label it before I send the notes. No, wait, before I send the notes.